In these notes, we're going to be looking at properties of logarithms, section 4.3. Since logs are a way of rewriting exponents or power expressions, it's not surprising that logarithms have properties that resemble the properties of exponents. So just before we get busy looking at properties of logs, just real quick remind you about some properties of exponents. And you can just watch this part of it right here without writing it down. All right, I've got 3 problems here. And what we want to do is we want to apply the properties of exponents. So when we know we have a product here with the same base, we can just add the exponents. So we could actually just jump from this step to this step right here, but just want to just point out that from a product we go to a sum. All right, here we have a quotient we're dividing. So properties of exponents say that we can simplify this by subtracting the 2 exponents. We take the numerator exponent, we subtract the denominator exponent, so 5 minus 2 is 3. And again, we'd probably just likely go right over here to this step by subtracting. So we go from quotient to difference. To simplify this exponential right here, we have a base x to the 5th, the exponential x to the 5th, to a power. So what we end up doing is we multiply those 2 exponents. And we get x to the 10th. So this is a power to a product. And we would probably just go right to here. The logarithmic properties are very similar to this. So coming back here to the notes, okay, we're told that logarithms have these specific properties. Let's make sure that we understand that b, m, and n have to be positive numbers and that b cannot be 1. All right, the product property for logarithms says that if we have log with some number base b and we have a product here, that this expression is equal to taking log with base b of m, that factor, plus log base b of n. So we're going from a product, m times n, to a sum right here. The quotient property for logarithms states that if we have a quotient, which that fraction bar indicates it, that we're not going to add the log base b of m to the log base b of n, that this quotient is going to go to a subtraction. So this is quotient, the fraction bar, to a difference, quotient to difference. And the third thing we're allowed to do with properties of logarithms is use what we call the power property. So notice in this log expression that we have log base b, and then we have some value m raised to some power p. And it's saying to us that we could take this p power and move it from a power position to what we call a factor position. So just moving the p to front into the front, and it becomes a factor, and everything else stays the same. So in this lesson, we're going to learn how to expand and condense logarithms using these properties. So expanding a logarithm means that we're going to use the properties to break that log expression up, which just means we're going to go from one log expression to more than one. And then we're going to do the opposite. Condensing a log expression means we're going to be given multiple terms, and we're going to want to put it back together. We're going to go from many logs to one. All right, so we're going to expand a log expression. We're going to break one log into more than one, and where possible, evaluate log expressions without using a calculator. All right, so in all of these 9 examples down here, we're going to apply the 3 logarithm properties. So we have to identify, do we have a product, a quotient, or a power? And then we could use the necessary property to expand. So I see I have log base 2. Here I have a product. 7's a factor and x is a factor. So this is actually equal to, I just don't have enough room here, so I'm going to come down in this space and expand. So think of this as your m from above in the product property, and think of x as your n. So let's put log base 2 on the 7 plus log base 2 of x. And before we leave this problem, let's look at each individual term to see if we can evaluate the log expression without a calculator. Well, I can't evaluate this because I don't know what x is. And when I look at what's going on here, I'm not going to be able to find an exponent for 2 that equals 7. I can't simplify this. Had 7, this argument, been 8, I could think about 2 raised to what power gives me 8, and I could simplify this to 3 if this 7 happened to be an 8. But as it stands right here, I'm not going to be able to simplify this log term right here. Example 2. I notice that I have a quotient, so I think it's going to be the quotient property, quotient to difference. So again, this is equals, but there's not enough room here, I don't think, so I'm going to come down here. So let's take log base 3, and we go to the numerator first. We start with the numerator because it tells us up here in this property that we take the log base b of the numerator minus log base b of the denominator. So log base 3 of 27, change to a difference, log base 3 of the denominator. This won't simplify because I don't know what x is. This part of the problem right here, the answer, this log expression can be simplified. Think about this as 3 raised to what power is 27. So this whole log term will simplify to 3. And then bring down the rest of the problem, this other log term. And that's our final answer. Okay, and number 3, I'm looking at peeking in at x squared. It's not a product, it's not a quotient, but it is a power. So I'm going to apply the power property. Again, this is equals. I might have enough room, but I'm just going to go ahead and come down here. Log base 5 of x, but what I'm going to do is I'm going to move the 2, the power in front, as a factor. I don't have to show the multiplication symbol. I can just leave my answer like this. So this is 2 times log base 5 of x. I can't simplify this part of the problem, this factor, because I don't know what x is. This is your final answer. All right. So here we're going to, in the remaining problems, probably look at a little more complicated situations where we might have to use more than one property. So let's study this for a minute first. I see 64 is a factor, x squared is a factor, so it looks like there's a multiplication dot in here, symbol, so that is the product property, but I also have a power on just the x squared, or just, pardon me, on just the x. 2 is not an exponent on the 64. So what order should we use in expanding? Well, it's kind of common practice, again, that's equals, to take log base 4 of 64 and then plus log base 4 of x squared. It's common practice, go ahead and break that product up first and then take a look at what you have and see if you're finished. Well, I have 2 numbers here, so I want to think about 4 raised to what power is 64? Well, you could start on the calculator and just start multiplying 4 times 4 and see if you get the target number of 64, and you will. 4 raised to the 3rd power is going to be 64. So this log expression simplifies to 3 plus. Now over here I can apply yet another property. This is a power property where I'm going to move the 2 as a factor in front. So I've got the plus, I'm going to put the 2 in front, 2 times log base 4 of x. So twice this log factor. This won't simplify, so I'm finished. Okay, in problem 5, I'm kind of looking at what I have here. I have a quotient. I'm going to use the quotient property. I also have a product in the numerator of 7 and x squared, and I also have a power on the x base. Looks like I'm going to use all 3 properties. First thing we might want to do is use the quotient property. So let's take natural log of the numerator minus natural log of the denominator. There's nothing more I'm going to be able to do here to simplify this term, this log term, so my attention should focus on what's going on here. This term is very similar to the problem in 4, so I have a product. Let's do that first. So natural log of 7 plus natural log of x squared. Let's go ahead and bring down the minus natural log of y. Now just go back and inspect each of these terms to see if there's more work to be done. Well, natural log of 7 isn't going to simplify to any nice number. Remember, this is base e. If I ask myself e raised to what power is 7, I couldn't find a nice number. So that won't simplify unless we use a calculator and approximate it to a decimal. So let's write down natural log of 7. Let's turn our attention to this term. We have a power, and I'm going to move the power in front as a factor. and then just bring down the natural log of y. And that's your final answer. So we're expanding log expressions. Notice we start with one log expression, but we end up with multiple, more than one log expressions. This is very helpful in calculus when you go to find derivatives, so we need to practice this skill prior to getting there. But at this point, let's just know that these are properties we can use for logs. Okay, look at 6. A lot of things going on here. We have a quotient. We've got a product in the numerator with a power. And in the denominator, we also have another product with the 4 and the x squared and a power here. So we're going to use many of the log properties. Let's start with the quotient property. Remember, this is equal. We'll come down here. So notice there's no base showing here. You might remember the understood base is 10. Do you have to write it in? No. Is it wrong if you do? No. So log of the numerator minus log of the denominator. Again, both these are base 10 if you wanted to write them in. Oops. Okay, let's take a look at each of these log terms. This term right here and this term, we can apply more properties. So I'm going to work on what I have here, 7y cubed. You don't have to put these in parentheses. It's not wrong if you do. It's not wrong if you don't. So working on this term, I see a product. So I'm going to do log of 7 plus log of y cubed. And then I know I'm going to be able to apply the power property and move the 3 in front of this term. Not this term, because the 3 exponent only goes on the y, not the 7. I'll do that in my next step. Let me turn my attention to this term. Minus. Now I think I'm going to put a bracket or a parenthesis, some kind of grouping symbol here, because when I break up this term, I'm going to have two terms that need the minus sign. So this is log of 4, and then this is a product, so it's to plus log of x squared. Okay, we're not done. Let's bring down the log of 7. I won't be able to simplify this because I can't find an exponent for a base of 10 that would give me an answer of 7. So I'll just leave this as log of 7. You could write the 10 in if you want, or you don't have to. Okay, let's turn our attention to this term. Okay, let's move the 3 in front. Okay, now what I'm going to do here is I'm going to distribute this negative sign throughout the problem. So minus log 4, and then minus, I have to distribute over here, but I'm also going to do this step in moving the 2 in front because I have the power property I can use. Okay, let's take a look at these 4 terms right here, see if there's anything we can simplify. Well, right here, 10 raised to what power is 4? It's going to be a decimal. I can't do it by hand. It's not going to be a nice number, so we're finished. Okay, let's look at 7. Okay, we have a little issue with this square root. We have a little issue with this square root in 8, and also a little issue with this square root in 9. So going back to 7, the first thing we want to do is rewrite the square roots. Okay, or actually I said square root on number 8, pardon me, it's the 5th root here. We want to rewrite these radicals with fractional exponents. So in problem number 7, natural log, let's put e to the x in parentheses and let's raise that product to the 1/2 power. The square root is on both e and it's on x as well, so you want to make sure and put parentheses around this part of the argument. All right, let's look at what we have here. I have a product with e and x, and I also have a power. In this case, we want to get rid of the 1/2 first so that we can apply the product property. So the first thing I'm going to do is I'm going to take the 1/2, because it's on both e and x, and I'm going to put it in front as a factor. So a 1/2 times natural log of ex. Okay, so this is equal, and then as I move down, these are all equal. Okay, I'm going to apply the product property now and go from product to sum. Just be careful because that 1/2 is going to be actually on that product, or on that sum, I should say. So it's a 1/2 times, let's focus our attention on this part of the problem. Natural log of e plus natural log of x. You could distribute the half and put it in front of both of these terms, or you could just leave it factored out, doesn't matter. One final look inside here. I can simplify this term right here. Remember, this is log base e, ln rewrites as that, and then we have e, and the understood exponent is 1. So these two will undo each other, so this whole term right here will simplify to 1. So I've got 1/2 factored out front, replace ln of e with 1 plus ln of x. And that's going to be your final answer. Again, if you want to distribute the half in, that's fine, but you don't have to. All right, number 8. Studying what I have here, I have a base 10. This is the 5th root of the quotient x over y. Let's first of all rewrite that. Log, understood base 10, 5th root of this quotient. So let's take x divided by y and raise it to the 1/5 power. Similarly, like number 7, let's get rid of this exponent with the power property. Move the 1/5 in front. Log of the quotient x divided by y. Notice that that 5th root was on both x and y, so that 1/5 power, which moved in front as a factor, should apply to both log x and log y. So 1/5, let's go into a bracket. Let's use the quotient property, log of the numerator minus log of the denominator. You could distribute the 1/5 in. It would go in front of both of these terms as a factor. Otherwise, you can just leave your answer factored out. I can't simplify either of these two terms because I don't have a numerical value for x or y. Okay, number 9. Log base 8. Notice we have the square root only on the denominator. That 1/2 power will only apply to x plus 1. The 1/2 power does not apply to 64 because 64 is not underneath the square root. Let's go ahead and do the quotient property first. Log base 8 of the numerator minus log base 8 of this denominator. I'll probably go ahead and do another step here and change x plus 1 under the radical to quantity x plus 1 raised to the 1/2. All right, looking at this term, 8 raised to what power is 64? Well, that would be 2. That does simplify. Minus. And then over here, okay, I don't have a product and I don't have a quotient here. I have a sum, but we don't have a property for that. The only property I'm going to be able to use is the power to the factor. So put the 1/2 front in front of this log. Nothing more can be done here, so we're finished. And just as a final look, notice that the 1/2, which was a power up here, only goes on this part of the problem right here because the square root was only on the denominator. And that's our final answer. All right, so these were examples of expanding a log expression, so let's just do the opposite of that. Let's condense a log expression. Meaning, as you can see here from these 6 examples here, that we have multiple log terms and we want to collapse them or condense them into just one equivalent log expression. So number 1, I see that I have a sum, so I'm going to go back to a product. And that's because I have the same base that I can use these properties. I want to make sure and point out that if this was log base 2 and this was log base 5, I couldn't use these properties. I've got to have the same base. So if you're asked to condense a log expression, it should be that the bases on all the multiple log terms are the same. If not, it's probably a typo. All right, for this one right here, this is equal to, there might be enough room here, but I'm still going to come down here. I see plus, so that means that I'm going to multiply these two arguments together. I'm going to collapse it. So log base 2 of the product of x and 3. Well, we don't usually write x3, we usually write 3x. This order doesn't matter. And then I'm finished. Right, number 2, same base. I see a difference, so I'm going to go back to a quotient. So I'm going to make a fraction bar. What goes on top? Well, whatever I see first before the subtraction sign. So x goes on top and the 3 goes on the bottom. You could put parentheses around here if you want, but you don't have to. Okay. In example 3, studying this term right here, there's no properties I can apply. This is just a sum in here. But this minus right here between these two log terms with the same base tells me I'm going to do the quotient property. Rewrite as a fraction. So log base 3, create your fraction bar right along the same line. What goes on top? Okay, whatever log term comes first. Whatever log term falls behind the subtraction sign, that argument goes in the denominator. You could put parentheses around this if you want. You don't have to. And just point out before we leave and go to number 4, okay, you can't simplify this fraction by dividing these x's out. Remember, if you're going to divide out this x, there also has to be an x in this term. All terms have to have an x in it if you're going to divide that x out. This is your final answer. Okay, number 4. I see a subtraction, so let's rewrite this as a quotient. 48's on top and 3's on bottom. Before I leave this, I might want to try and do some simplification. Use your calculator, divide 48 by 3. You're going to get log 2 base 2 of 16. Well, before we leave this problem, let's think again. Okay, does this have a nice answer? 2 raised to what power is 16? Well, if you take 2 and multiply it multiple times on your calculator and you count, okay, 2 raised to the 4th power is going to give you 16. So the final answer for this problem is 4. Okay, in problem 5, I see a plus between two log expressions, so I'm thinking product, but we also have this little situation with this factor in front here. I'm going to take and make this factor, yes, 1/2. Okay, I'm going to move it back up into the exponent position because that property says I can move exponents to factors, and then I can also go the other direction and make this factor a power. So before I use the product to sum, or backwards, sum going back to product, I'm going to make this a power. So natural log of 3 plus natural log of x to the 1/2 power. I'm going to go ahead and rewrite this as the square root of x. One-half power means square root. One more property, I'm going to go back to a product. So I'm going to drop both logs. So I'm going to only have one log, and then I'm going to multiply, because of this plus sign, these two arguments, 3 square root of x. And that's your final answer. All right, 6. Notice that we have 3 log terms here. Okay, and in the front, I see a factor here. That's going to become an exponent on x. This factor of 7 is going to become an exponent on y, and 3 is going to become an exponent on z. That's going to be the first thing I do, is take care of the factors and make them powers. So for here, base of x, power of 4. This next term, base of y, power of 7, minus here, natural log of z to the 3rd. Okay, I haven't condensed yet, but if I read from left to right, I see a plus means let me grab these two terms and let me make these two terms go back to a product. So natural log, and then I'm going to have x to the 4th and y to the 7th, and I'm going to multiply because of the plus. So x to the 4th, y to the 7th. Don't forget you still have minus natural log of z cubed. We still can use another property, that's the quotient property, because of this minus sign here. So this is going to become your numerator in your fraction, and this is going to become your denominator with just one log in front. So natural log, fraction bar, x to the 4th, y to the 7th, z cubed. Again, you could put parentheses, but it's not necessary. That's your final answer. All right, for this last objective right here, we're going to switch out of expanding and condensing logs using the properties. We're going to go to what's called a change of base formula. And this formula is going to help us find the values for logs that we can't do by hand, so to speak. So, for example, when you look at this example of log base 5 of 7, prior to this change of base formula, if we tried to simplify this, what we would do is we would have taken 5 as a base, raised it to the x power, and said, okay, that has to equal 7. Well, there's no way, based on what we've done before, that I could take 7 and rewrite it as a power of 5 so I can remove the bases of 5. So this one right here doesn't have a nice answer. So without a calculator, you'd have to just leave the answer as log base 5 of 7. You can't simplify that. With a calculator, we can use the change of base formula and get a numeric answer that's a decimal. So 5 raised to what power is 7? So if we think about that for just a minute and just predict what the answer is, I know if x is 1, my answer would be 5. I know if the exponent is 2, 5 squared would be 25, so that would be too big because my target answer is 7. So if I predicted what I think this exponent should be to get a value of 7, okay, this exponent's going to be greater than 1, but less than 2. So it's going to be some decimal between 1 and 2, probably closer to 1 than 2, since 5 squared is 25. So let's just kind of have an idea of what we think the answer is going to be and use the what we call change of base formula to find the answer and see if our prediction is close to what the calculator tells us. Okay? All right. So right now, just remember that I cannot find the value of log base 5 of 7 unless I have a calculator. Well, how do we do that in the calculator? Well, change of base says that, and let's just look at this one at a time. The change of base formula says that if we change this logarithm, which is what we have here, okay, to this format right here and use a calculator, we can find an answer. Well, what is this format? Well, over here, we say it's the log of the argument, which would be a, divided by the log of the base, in this case would be c. So log base b of a divided by log base b of c. Well, where does b come from? This base can be any base you decide you want it to be. So for example, we could rewrite this log expression as log of 7 divided by log of 5. Notice this base 2 is just something that we inserted. It's saying that this answer equals this change of base formula. Or what if we decided not to use a base of 2 and instead we used a base of 3? And we still had the 7 and the 5, which comes from the problem, 7 and 5. The base is the new thing we're inserting, saying that this would equal the same as these previous two. Well, if I can use base 2, base 3, I can use base 4. I still have 7 and 5. Probably more importantly, I probably would use base 10. Oops, there should be a 7 here and a 5 here. This is the understood base of 10. Okay, I'm probably going to use this change of base formula because on your calculator, you have the log base 10 key. Most calculators don't have these other bases, 4, 3, and 2. If I don't use this change of base formula, I'm probably going to use this change of base formula. Notice that natural log is base e. Okay, same thing here. Same log function here and here, 7 and 5 from the problem. I'm either going to use one of these two formulas, this one or this one. And that's because I have the LOG button and I have the LN button on my calculator. So it says which base would be helpful to use? Well, not 2, not 3, not 4, or any other number. Probably log or LN, because both these appear on your calculator. All right. So let's see how we can calculate these logs to 3 decimals by using our calculator. Okay. This has an answer. Okay. Oh, pardon me. Let me go back up here. Let's go back up to this problem because we made a prediction that we think the answer is going to be a little more than 1. So on the calculator, okay, I'm going to use this formula first. So if you're using this little scientific one, okay, we want to be careful with a fraction. I'm going to open a parenthesis, maybe, open a parenthesis, and I'm going to find the log key. It is on this calculator right here. Notice a parenthesis open, so I'm going to put a 7, and I'm going to immediately close that parenthesis around the 7. And then I'm going to close another parenthesis here, because I want this to be my numerator. And then divide by. You can open another parenthesis if you want down here in the denominator. The critical part of it is, well, yeah, we want to open another parenthesis, sorry. Okay, parenthesis, and now let's write in log here. And let's put 5. Let's close the parenthesis once for the 5 and close the parenthesis for the denominator. Press enter. The value I get is a little more than 1, closer to 1 than it is 2. It's very close to what we predicted. Okay, so my answer here to 3 decimals is 1.209. Let's confirm that we get the same answer by using a different log, the ln, the base e. So I'm going to clear this out. I'm going to do an open parenthesis because I'm creating a fraction. I'm going to do ln instead of log. It's right here. 7, close your parenthesis again for the numerator. Divide by, open parenthesis, ln of 5. And close your parenthesis twice. Yes, we got the same answer. So it's really your choice. Which base do you want to use? The base 10, the log button, or the base e, the ln button? Doesn't matter. All right, let's look at example 1. 16 raised to what power is 26? I don't know what that is. Okay, I don't have enough knowledge about that decimal, so let's use the change of base formula. This is equal to, create a fraction. Okay, think about what this is saying. The log of the argument divided by the log of the base. So I need a log here, and I need a log here. And I'm going to do base 10. I know it was 16 here, but when we do change a base, it doesn't matter what base we use. We're going to use 26 on top after the log, and we're going to use the base down here after the log. So let's go to our calculator. To 3 decimals, 1.175. Okay, I'll just finish doing the setup of these and then record the answers, and then you can practice on the calculator. Log of the argument divided by log of the base. And I change these to base 10. I'm going to use ln this time. Natural log of the argument divided by natural log of 5. And here, I'm going to go ahead and change to ln, natural log of 19 divided by natural log of 0.3. Just make sure you're able to do the keystrokes on the calculator. Okay, I know I'm running long, but if you are going to use a calculator, maybe a more smart calculator, advanced calculator than this one, just real quickly, let me show you what you might have on your more advanced scientific. No graphing calculators allowed, but if you want to use a scientific calculator and you actually have in a built-in template to find the log answers, then you can use that. For example, on this graphing calculator that I'm going to show you, you may have the same keystroke on your scientific, and feel free to use it. So on my graphing calculator, I'm going to go to a window where I'm going to pull up a template. Notice that right here, I don't have to use the change of base like I did here because I'm able to enter everything the way I see it. So right here, I'm going to enter 16 as the base. I'm going to do my right arrow, and I'm going to put 26. Okay, so I should get the same answer I got by doing change of base. It's just that this calculator is a little more advanced, and it has this template to find the answer. And it is the same. So just look at your scientific calculator. If you have this nice little built-in template for log, so you don't have to do the change of base, feel free to use that as well.